Ignition sequence start. 6, 5, 4, 3, 2, 1, 0.
This is one of the self-healing wire test specimens. The film that you see here is a high-performance film that contains microcapsules. The microcapsules contain a healant that when the wire is damaged, it'll be released and repair that location. As you can see here, the wire's been damaged, and this particular sample we did not get much healing. We're working on optimizing this method so that we can get healing, but this is still a very low technology readiness level project, and there's still work to be done in this area. An alternative approach to the microencapsulation technology is using materials that actually have some memory and tend to flow without any external stimulus. This particular test specimen here is a composite that contains a flowable material in the center of two high-performance materials. This material was actually developed in the laboratory here at Kennedy Space Center. When this material is punctured, it actually is able to flow and heal itself without any external stimulus. This particular sample was punctured completely with a needle, and within 2 hours was able to hold pressure above atmospheric pressure without any external stimulus, so that it completely healed itself. Another new technology being developed in the Polymer Science and Technology Laboratory that ESC is supporting is a damage detection system that we utilized on space structures. The system involves using conductive traces and a monitoring system that, when impacted by micrometeoroid and orbital debris, will give a signal to the user that they've been impacted. The system can detect currently damages as small as 1.5 millimeters and up to 6 inches in diameter. The typical panel used in the system is this type of panel, and it has a large number of conductive traces embedded into this system, as well as some structural material that was typically used in inflatable structures. So the sensing panels that we've developed are connected to a printed circuit board and a monitoring system, and then are integrated into a part of the overall avionics package of, say, the spacecraft or habitat in which it's actually mounted to. And this chart here shows some examples of how the system works. The system is mounted into an enclosure. In this case, the enclosure is sealed, and it's placed on the outside of a structure, and the system is talking wirelessly with a monitoring program or computer that's actually monitoring all of the lines every second. So it can do, at this current stage, 672 lines per second. And it's monitoring the panel and looking for damage. And damage is induced to the panel, and then damage appears on the graphical user interface. In this case, it's color-coded to give you the depth of damage. So this system is designed to provide multi-dimensional damage detection. It tells you the location, the depth, and actually the angle of attack or approach of the micrometeoroid or orbital debris that impacts the system.